What's up, guys? It's Mr. Bringle, and today we're going to look at our graphing practice. I'm going to move this webcam over here. So you'll have a Google Doc that goes along with this, but I'm just going to be looking at the Google Sheets because I'm primarily just going through the graphing here. So let's just jump right into it. Right here, you've got a data set that involves volume and pressure. So I just want to be clear that whatever is in the first column, doesn't matter where you're graphing this, even if they're in these two columns over here, whatever's in your first column will go on your x-axis. That's the way the program does it. So that's always going to be your independent variable, the thing that you're manipulating, okay? And when we're doing experiments, you'll need to decide what that is, okay? But here it's already set up for you. So this goes on our x-axis. Pressure will end up on the y-axis, okay? When we go to graph this, you're going to highlight from the title all the way down to that last number there. So from volume to 0.4. And there's two ways to create a graph. You can either go to Insert and then click on Chart right here, or you can highlight the data and just, this is what I normally do. Up here on the toolbar, there's a little graph button that will also insert the graph. So a couple things here that we've learned about in terms of how we want to make graphs, but in here we like scatter plots or scatter charts. So right here under setup, you can choose your chart type. We're going to scroll down and find the pie charts because the scatter plot is right below the pie chart. So we'll click on scatter, and now you can see it's just put the dots here for us. Okay. Now I always come down here and check these three boxes to make sure that they look just like this. Sometimes these things will be clicked or unclicked, and it just makes your graph do weird things. So just make sure that these bottom two have check marks on them, and the first one is blank. Now what we'll do is we'll go over to customize, because the next step would be looking at our chart title and the axes here. Okay, so in the title, there's two ways to edit this. If it already has words on it, you can double click it, right? And then I can just start typing right here. Okay. If it doesn't already have words on it, by the way, if your editing tool goes away, just double click on your graph. If it does not have any words on it, you can click right here under Customize Chart and Axis Titles, and then this drop-down menu right here, you can choose horizontal axis, vertical axis, or the chart title. Okay, so we'll look at the chart title here, and it's got some weird formatting here. It looks like it has like entered down to multiple lines, so we don't want that. But the other thing is that we don't want units in our title. It just gets too busy. So really what we want is just pressure versus volume. Now, again, based on what we talked about in class, the format here is always whatever you find on your y-axis is what you put first. So pressure is on our y-axis. So pressure versus whatever's on our x-axis, which is volume. Okay. Now let's go ahead and check the horizontal axis, which is volume. We do want units on this, but they're not showing up on the graph for whatever reason. Now they are. So always just double check that, because it should theoretically put whatever you had in your title over here. So pressure in pascals and parentheses should be right here on your graph too. Okay. And for whatever reason, it's being a little bit weird here. So looks like I just had to space that out. It's good to go. So now we have a title, we have a labeled y-axis, a labeled x-axis. The next step would be to decide whether we need a trend line and an equation. Okay. Now, this is not a linear graph. You only need an equation and a trend line for a linear graph. However, I'm going to show you, you're always going to kind of want to click on series right here. So customize in series. And if you scroll down to the bottom, there's this trend line box right here. Okay, so we can click that, and then you can choose what type of trend line you want. If it's linear, then you would choose linear. This is not linear. So if it's anything other than linear, you're going to click on polynomial. Okay, so now you can see this is kind of curved, and it looks a little weird right now, but don't worry about it. Okay, now the thing that I want you to really pay attention to is this box right down here that says show R squared right there. That R squared value helps us determine whether this is curved or linear. Okay, so when I click on this, it's actually not showing up. Let me hit use equation here. Okay, I'm not sure exactly why it's doing it like that, but ignore all of this and just look at this R squared value right there. Okay, Now let's pay attention to what happens when I change the trend line from polynomial to linear. Watch that number. Right now it's 0.52. And I click on linear and now it's 0.34. So that number went down. The R squared value is basically telling you how well this trend line fits your data. And the closer it is to 1.0, so is that would be a perfect fit. Okay, so 0.34 is really far away. To be fair, 0.52 is not a good R squared value either. This graph is just a little weird, not a big deal. You would want that number above 0.9, and really above 0.95 would be best. That would be like, that fits really well. But this is how you can kind of determine if it's close. You're not sure if it's linear. And we'll look at one of those examples here in a second as to which one it is. So anyway, because this is curved, we don't need the equation. We don't need the R squared value on there. We can go ahead and get rid of it. And then you can just leave this graph as is at this point. Okay. We'll move a little bit faster through the next ones here. So once again, time's going to end up on the x-axis, position's going to end up on the y. I'm going to go ahead and highlight all of it. We're going to hit the chart button there. Okay, so looking at this, this one looks like it could be linear, or it could have a little curve to it. So we'll want to look at that R squared value for this graph. Now, looking at my title, I'll edit it over here this time. I want position versus time because position is on my y-axis. That's what we list first, versus the x-axis, which is time. And I don't want units in my title. I do, however, want units on my axes, and these are set up fine. Position in meters, time in seconds. Good to go there. Okay, so now that we've checked all that stuff, and I'm just going to double check these three boxes down here, we'll hit customize. I can go to series. By the way, if you want to change colors, background, stuff like that, you go to chart style. You've got background and border colors. If you click on chart and axis, or I'm sorry, the series button, you can change your colors for these dots and things like that. You can make them squares or triangles, whatever you want. So now, I'm not sure 100% whether this is linear or not. So what I'm going to do is I'm going to click on this trend line box down here. I'm going to scroll down. Right now it's a linear trend line. Let's look at the R squared value. So it's a 0.929. That's not bad. That's actually pretty good. But let's see what happens when we change it to a polynomial trend line, which would be for a curved graph, so nonlinear graph. And look at that, it goes to a 1.0. So that means that this graph is curved. This is a parabola because this trend line fits perfectly with the parabola shape. The 1.0 R squared value tells us that. Even though it's close to a 1.0 for linear, it's still not. Remember, 0.9 and above is good, but 0.95 and above is what we're looking for. So this is a curved graph. Now, I don't care if you want to leave this on here because it helps you. That's totally fine. You don't need the trend line for the curved graphs. You really just need it for linear ones. And because this is curved or nonlinear, we do not need an equation. It won't help us out. We're only going to use that equation when we have a linear graph. So we're done with graph 2. Let's move to graph 3. We'll go through that same process. Mass will end up on our x-axis. Velocity will end up on our y-axis. We'll highlight everything, hit the chart. So this one looks linear already. We'll make sure it's a scatter chart. Check the three boxes. Go to customize. Let's look at our titles here. So I'll go back and do it this way again. So on our chart title, I can edit this right here. And we'll just do velocity versus mass, which would be y-axis versus x-axis here. And then let's look at our horizontal. Mass in kilograms is good, and vertical velocity in meters per second also good. So now we can click on series. I'm going to get rid of this, and I'll click on series here. And let's go ahead and put that trend line on it. And this does look linear. If we go to our R squared value, you can see it's a 0.999 for linear. And that's what we thought it was, so we're good to go there. Now, for this, we're going to use an equation, and I'm going to get rid of the R squared value because that's really just to check to see what we think, whether it's linear or nonlinear, right? So I'm going to get rid of that. We're good to go. Now I've got this equation up here, and it doesn't look like much, but since this is a line, this equation is in the format y equals mx plus b. So this number, negative 3.02, is m, which is your slope. So there is a slope of negative 3.02. Okay, so, and that's sloping downwards, so that makes sense. If it was positive, it would be going up the other direction. Okay, times x, so m times x, which would be whatever's on your x-axis, plus b, which is your y-intercept. Now, this looks a little funky right here because it says that the y-intercept is 25.5, but this appears to intersect below 25. So sometimes what happens is your graphs get, the formatting gets messed up. What I do in these situations is I change the axis here. So notice that the y-axis only goes up to 25. So if I click on the vertical axis and say change that to 26, it should include that. So it went ahead and went up to 30 because it's going by tens. But notice how now we can see where that intersects there. And we need to change our x-axis too because it still looks a little bit too low. So I'm also going to go to my horizontal axis, and I'm just going to make sure that this is on 0. Sometimes the minimum value is defaulted as something other than 0. Notice that it showed up there, and now that looks better. That looks like it's halfway in between at 25.5. So it's just little things like that that sometimes Google Sheets will kind of be goofy about. You just gotta use common sense and think about it. So when I look at this number and I saw 25.5, and then I looked at that y-axis or the y-intercept, I thought the scaling here is off. So we're able to fix that pretty easily. Okay, so we're done with this graph. Title, labeled axes, trend line. We got an equation. Good to go. Last graph here. So time ends up on our x-axis, velocity ends up on the y. And you always want to double check that because sometimes, again, Google Sheets will just like flip them for no reason. It'll just happen. So you always want to double check these. Okay, so this is another example where this looks like it could be linear, but there is a point right here. So if you kind of follow that arc, to me, it sort of looks like our Groot graph too. So we'll want to take a look at that. We got a scatter chart. We check the boxes. We're good. Hit customize. Let's look at our titles here. Actually, I'm just going to do it this way this time. So we will get rid of the units up top. We'll check to make sure that our axes are labeled with units, velocity in meters per second, time in seconds. Good to go. Okay, now we'll check series, and we'll go to trend line, and we'll show the R-squared value. So, all right, so the linear R-squared value is 0.925, which is not bad. That's decent, okay? Which usually when you've got one that's kind of in between, it's going to be a decent R-squared value either way. When we change it to polynomial, notice that it goes up to 0.981. So this really fits the Groot shape much better, the square root function. So we're going to go with that this is nonlinear and that it is a Groot-shaped graph. Okay, so this concludes part 1 of the graphing practice. This is more for you guys just to learn how to graph in Google Sheets. And then ultimately what we always want to do with graphs that are nonlinear is that we want to linearize them. So we want to change them into a linear graph. And I am going to show you guys how to do that in the next part. So that'll be it. If you have any questions, make sure to let me know.